All right, so let's take a look at the second part of 1.3. So remember, we're talking about functions. And functions, the simplest terms are pictures you can draw to pass the vertical line test. Okay, so let's look at this one. Starting off with a calculator question right away. Find a complete graph and then determine the domain and range. So we're going to do some more practice with domain and range. Well, let's think about the domain first. Does this problem have a fraction in the formula with a variable in the bottom? What do you think? Mike? No. Does this problem have a square root in it? No. No square root. That means the domain can be what in this case?
Any real number?
Any real number. You can take, the only thing you're doing here is you're plugging in a value and you are cubing it. There is no number you can't raise to the third power. So the domain is all real numbers. The way we can write it, lowest, highest, and then the symbols on the end, whether or not you can reach it. Well, you can't reach negative infinity, and you can't reach positive infinity. Okay, range. Range is a little harder to figure out than domain, which is why we usually graph it. And then we take a look at how high and low the graph goes. Domain is left and right. Range is up and down. So on the calculator, you're going to make sure you turn it on. Press the y equals button. And we're going to type in 16x minus x cubed.
I suggest you use the window of 30 of x 30 negative 30 and y is 30 and negative 30.
Okay, we may have to adjust it. I'm going to start with the standard window to show you that that does not work out well.
How do you do x cubed?
Oh, yeah.
This one now.
So to do an exponent of 3, press the up arrow on the right-hand side, right below the clear button, and then you can press 3. Just make sure, though, if you had more to type after that, you're still up in the exponent. So if you keep typing, your numbers are going to stay up there. If you press the right arrow, it drops back down out of the exponent. Not important here because we don't have anything else we need to type. Now, when you're dealing with a polynomial, this exponent, if you subtract 1 from it, it tells you how many times the graph could turn. So this one could turn up to 2 times. Well, kind of looks like it might be turning, but I think it looks like it's off the screen.
I see the x is 30 and negative 30.
So we could try,
All values will be 30.
I don't think you need to set the x's any bigger. I think if you set the y min and max to negative 30 and 30, you should see a graph that looks like that. And it's not going to do anything else interesting. This part on the right is just going to keep going down forever. This part on the left is just going to keep going up forever. How do I know it's not going to turn again? Because I know that this exponent is a 3. Subtract 1 from it, that means it can turn twice. I can see both turns on the screen. Nothing else can happen. Okay.
So the range is going to be negative in front and negative infinity and then infinity.
Yes, the range in this problem will also be negative infinity to infinity because it goes down forever and it goes up forever. Yeah.
I don't know what I'm doing wrong because there's nothing on my graph.
Okay, you typed in a graph just like that.
Yeah.
And you set your window.
Yeah.
And the equation sign here is bold, like it has a black box around it.
Yeah.
Let me take a look. cubed. So right now it doesn't have it. Now it does. So now if you hit graph, okay. Any other questions on getting that picture?
When I go through the exponent, it doesn't actually make it an exponent. It writes down the carrots.
Okay, yeah, sometimes it can do that too, depending on the settings. If you have a calculator that doesn't show something as an exponent, that's probably because under mode, where's the settings?
I'm obviously reading out
Yeah, degree and radian won't matter. But there is a setting, I thought it was called math type. Oh yeah, math print. So if you put it on classic,
Oh yeah.
it'll show mine as an exponent if I type it in the future, like this.
Yeah.
It'll show 16 with that little caret symbol. But if I put it on math type, it'll show it as an actual exponent. I like the math print better.
Yeah.
It's under mode. It should already be on it in mode, but if it's not, it's the first option when you press mode. Yeah. Yep, just sign up. So what did we say the range would be in this one? Yeah.
Negative infinity to infinity.
Yeah, because range, you're looking for how high and low it goes. And if you're not sure, you can set your Y max maybe negative or positive 100, and you can do your Y min negative 100, but you're just going to see it keep going down forever on one side and up forever on the other side. That's a characteristic of all polynomials that have an odd exponent as the highest number. You don't have to know that yet, but whether you change this to a 3, 5, 7, these two answers would stay exactly the same. Now, if you make it an even number, then it's going to look more like a parabola. Parabolas don't go up and down forever. That's a little different. But odd ones, they will. Yep.
It's my calculator is not graphing in the right graph. The same graph I'm typing. Same thing.
Is it 16x minus x cubed? And you set your window?
Yeah. Well, I just zoomed out a little bit, but it's making a parabola.
16x I'm not sure how I should have looked. I didn't see exactly. It looks. Could have just been the button you pressed when you typed it in.
I just clicked enter and then went to search and graph.
Did anybody else not get a picture, or anyone else not get that picture? And that was it. So as far as finding a complete graph, I would say x min and max, negative 10 and 10. Y min and max, negative 30 to 30. Works. Not the only right answer, but definitely one of them that works. All right, let's try this one. So this is a word problem, and it says that we have a swimming pool with dimensions 30 by 50, and there's a sidewalk around the pool that's the same width all the way around. We don't know the width of the sidewalk. That's what we're going to find. Okay? But we're going to call the width x. We know that the area of the sidewalk is 600 square feet. So there's a lot of words and numbers here. What do you think a good approach would be to start thinking about this problem and make it easier to think about on this? I guess what we might want to try to make this easier to think about. It's one of the approaches we mentioned last week when you're solving a problem. Yep. Yep. A picture. This is absolutely a problem that you really want to draw it out so you can see what's going on. So we have a pool, and then we're going to draw a sidewalk around the edge of the pool. So here is our pool. And now I'm going to put a sidewalk around the edge of the pool, and it's the same width all the way around. Okay, so here's our, I wanted blue for water. There's our pool. Okay, what do we know? What's one thing I know about the pool?
It's 30 by 50.
It's 30 by 50. So the pool is 30 by 50. Okay, so we know that. Let's fix that. Is there anything else I know in this problem?
Does it matter which side is 30 or 50?
Not a
Well, it says a rectangular pool, so I would make the longer side. Yeah, that's not a great, it doesn't really matter. That's an awful way to write it. Yeah. Why don't I do 50 by 30 just to make more common sense. Thank you. But the answer is no, it won't matter. Well, I know the width of the sidewalk. What is that?
We don't need this.
X. We don't know the number, but we at least know how we're going to represent it. It's X all the way around. It's as uniform as I could make it.
And it's 600.
And yeah, so let's, the abbreviation, let's do area. I'll just write A sub side, meaning area of sidewalk. Maybe I should write out the word sidewalk. It's 600. So we definitely need a formula involving areas. So the area of the sidewalk is this region in red. Does anybody see how we could get the area of the sidewalk visually from the two rectangles in that picture? Yep.
Is there any way we can get, well, I know we can get the area of the pool, can we like add them together, add the areas together, and then subtract for our measurements, or divide?
Okay, we can do some kind of subtracting.
Can you go back over there now? Because I'm trying to see, like what the top, what was 600 feet?
The 600 is the area of the sidewalk. That was in
Not
square.
without the pool or with the pool?
No, not just the sidewalk.
Okay.
So I like the idea of using some kind of subtraction to get that area in red based on the two rectangles. Anyone have? Yeah, Richard.
You can take like 50 plus 2x is that one side, the longer side, and there's 30 plus 2x. This is the sidewalk, and then you take that and subtract the space of the pool.
Pool, yeah. So if you take, let's just call this like the big rectangle. So let's say the area of the big rectangle, and you subtract out the area of the pool, you will be left with just the sidewalk.
Very good.
Any question? We're not even dealing with numbers yet. That's just the concept. Any question on the idea? I'm going to take the big rectangle, subtract out the pool, and you'll be left with the area of the sidewalk. Now, the area of the sidewalk, we know. How much is that?
600 square foot.
600. Let's come back to the area of the big rectangle. We already started to talk about it a little bit, but we'll come back to that. The area of the pool, we know. Or at least we could figure out.
Yeah, it's 1,500.
1,500. And now the area of the big rectangle. Well, I need to know how long that side is, and then I need to know how long that side is.
It's going to be 70 by 30.
How long is this bottom side?
It's like 50 plus 2x.
Yes, it's 50 from there to there. So that part's 50. But then you have this part, which is x, and you have this part, which is x, and that part is 50. So the big rectangle length is 50 plus 2x. And what about the width?
Same thing, 30 plus 2x.
Yeah, from here to here is 30, and then that's x, and that's x. So the width of the big rectangle is 30 plus 2x. Now, we just have to do out that equation and solve for x. Okay, so we've got to FOIL the two sets of parentheses. When we FOIL that, 50 times 30 gives me how much? 1,500. And then 50 times 2x and 30 times 2x is how much?
60x and 100x.
And that's a total of?
160x.
Yep, 160x. And what about 2x times 2x? 4x squared. So we're getting into a quadratic type of equation. Minus 1,500.
So and it would just be the 160x plus the 4x squared.
So that 1,500 cancels out. And if you did a lot of these problems, that 1,500 would cancel every time, whatever that number was. Now there's something we could do, it's not necessary, but it does make the numbers a little easier to work with.
Complement greatest common factor.
We could divide through by anything that's a greatest common divisor. So yeah, divide everything by 4. At least the numbers are a little smaller. And when we go to solve an equation like that, what do we normally like to get on one side by itself? Does anyone remember? What is it?
The variable.
Well, we're not going to be able to isolate the variable because it's a quadratic. So we're going to have to get something different on one side first. Yeah, we usually like to get 0 on one side. So what I would do is just move the 150 to the other side. And I'm rewriting it in what's called descending order. Highest exponent, next lowest exponent, and my constant. Now I will tell you that is not factorable, so we're not going to be able to solve it with factoring. What's another method you can use to solve a quadratic type problem?
Complete the square.
You could complete the square, absolutely. I'm not going to do it that way, but you definitely could. Yep. Yeah, quadratic formula. What's A in this case? 1. And B? And C? Negative 150. Okay, so fill that into your quadratic formula and see what you get. So we got negative b plus or minus the square root of b squared minus what comes after the b squared? 4 ac. Good. And that's all divided by
2 or is it plus
2. 2a. But in this case, a is 1. So. Now, right here, I'm subtracting a negative, so might as well just make that positive. And we have negative 40 plus or minus, well, 4 times 1 is 4. What's 4 times 150?
600.
600. And what's 40 squared? 1600. So 1600 plus 600. 2200. And we're just going to round that off, so there's no reason to really try to simplify that square root. I would just type it in on the calculator and see what you get. So we've got, I'm going to do it this way, the square root of 2200. Then I'm going to do plus the negative 40. And then divide it by 2. So that's about 3.45. Just the sidewalk is just about 3.5 feet. Now, I didn't do the other one, the negative. So that's negative 40 minus the square root of 2200. Well, I don't even need to divide that by 2. How come? I can just stop there with that one.
How do you get a negative space?
Yeah, you can't have negative width to the sidewalk. So even though the negative answer makes sense algebraically, this is a problem about width of a material. It can't be a negative number, so the negative answer doesn't make sense. So the only answer here that does make sense is about 3.5 feet for your sidewalk.
Can you write the quadratic formula out with just the number, like with just the letters?
The letters?
Yeah.
Yep. So again, something you would have probably done in Algebra 2, you would have reviewed it. Maybe geometry, it could come up somewhere. Not really as much though, but it's more Algebra 2 and Algebra 1. Any question on that? All right, so one thing we are going to look at a little bit, a couple different times, is what's called projectile motion. And there is a formula that we will use whenever we talk about projectile motion. If you take physics, you might see a different number here. It depends on how you're measuring things, if it's like feet or inches or different things. We measure things in feet in this class. In physics, you probably would use meters. But what this formula does is, you've got an object that's traveling like that, it's projectile motion. Even straight up and straight back down is technically projectile motion formula. To figure out how high your object is, you have to know 3 things. One is how much time has gone by since you launched the object. Our time is measured in seconds. What was the initial velocity of the object? Meaning the second that it left the device that launched it, how fast was it going right at that point? And the other thing you'd need to know is how high was the object when it was launched? Was it launched from the ground? Or was this object on top of a building and launched like that? But as long as we know those 3 things, time, initial speed, and initial height, we can figure out where our object is.
Yes. After the V, is that a small O or force as well?
That's V sub 0. So anything with a sub 0 usually indicates like initial amount. Yeah.
Is that a negative 16? Is that an example of like seconds, or is that a?
No, that's part of the formula. You will always use a negative 16 in the formula. That has to do with the acceleration due to gravity, the negative 16.
Negative 16 is time.
No, time would be t. Negative 16 is the coefficient of t squared. And the negative 16 comes from the gravity.
The time is basically the x-axis.
time is the x-axis, and then
Right.
height is the
You
y-axis.
can't go down into negatives because
Correct.
nothing happens before.
Right, nothing happens before 0 seconds. There's no such thing as plugging in like negative pi into this for t, because time can't be negative. Yep. Height can't be negative either. Height can only be 0. That's as low as height goes. Yep. Yep. Okay. So this one says that we've got a rocket being shot from ground level. And the initial speed of the rocket when it leaves whatever launched it is 64 feet per second. What time will the rocket be 50 feet above the ground? Okay, so let's see if we can figure that out. Well, the first thing we need to do is write down that formula with our information. So height as a function of time equals negative 16t squared. Now we have to start filling stuff in.
Initial velocity.
The next part is initial velocity times time. What was the initial velocity? 64. And the last part is initial height. Bless you.
Bless you.
What's the initial height in this
Thank
one?
you.
Ground level. So ground level means that the initial height is 0. There is no initial height in this problem. It's just plus 0. You don't need to put it. So there's your formula that you're going to use.
It's similar to a quadratic.
It's similar, yes, it is a quadratic, it is a parabola, and because of that negative, the parabola is going to open down, so the path is going to look something like that. And we're going to figure out when it hits 50 feet. We're going to do it graphically. I could do it with the quadratic formula, but I'm going to do it on a picture. Now, when you launch something, as long as 50 feet isn't the maximum, it's going to hit 50 feet twice. It's going to hit 50 feet on the way up, it's going to go above it, and then it's going to hit 50 feet back on the way down. Where would the 50 get plugged in for?
The ST.
S of t. That gets plugged in for that whole side. We're solving for time. So 50 equals negative 16t squared plus 64t. And as Richard said, it's a quadratic. It's exactly like the quadratic we just solved, except I'm not going to put everything on one side and use quadratic formula. I am going to graph it. I could use quadratic formula, and I would get 2 answers. But let's see if we can graph it.
They do an intersection.
Yep, we're going to find the intersection points. So we have to graph 2 different things. We have to graph 50 on y1. And then we're going to graph negative 16. You got to use x as your variable. You can't use t. That's fine. We use t on paper, but the calculator can only do x. Plus 64x. Now, before we graph it, we got to check the window. And x represents time. What's the smallest amount of time that could go by? 0. 0 would be the smallest number of seconds that have gone by. You can't have negative. The maximum amount of time we don't know. That's how long it's in the air for. Let's leave it at 10, and if the parabola goes off the screen, we'll make it bigger. Y is the height. Well, what's the lowest that this object would ever go? 0. And the highest we don't know, but we're gonna hope it hits at least 50. Let's maybe go up to 90. If the top of the parabola goes off the screen, we need to go higher. Okay, so let's try that as our window. There's my line that marks 50 feet. And there's my parabola that represents the height of the object. And as we already kind of said, how many times does it look like it hits 50 feet? 2 times. So we're going to have, we'll call it T1 and T2. There'll be 2 different times. And does anybody remember the button we have to press to figure out exactly what that time is? Second, calculate, yep. Intersect. Pick a point somewhere on the blue. Pick a point, I'm hitting my cursor to the left until I see it. Pick a point somewhere on the red. And now the guess is important. Why is the guess important? Right, it can only do one at a time, so it's going to give me whichever one it's closer to. If you put it right about there, it's going to give you the one to the right.
Wait, how did you do that again?
We'll do it again on the left. So hit enter, and on the way back down, after about 2.94 seconds, the rocket will be coming back down, and it'll be at a height of 50 feet.
I think I messed up.
Okay. Well, let's do it again.
No, I think I messed up on the equation. But Hager 16 x squared plus 64x. I'm doing a different problem.
Let me take a look at it after. We'll see. So now we have to find the intersect one more time. So second calc 5. Pick a point anywhere on the blue line. Right by trace. Up at the top. Pick a point anywhere on the red. And now move your guess closer to the left side. Hit enter. And it says on the way up, it's going to cross at about 1.06 seconds. Those would be the 2 numbers that you would get if you used the quadratic formula and you did the plus or minus. But that's just a different way, so you don't have to do plus or minus.
I don't know how to do it. I don't know how to do the intersect.
The intersect, you press second, calc,
Yeah, I got it.
and then option 5. And then you have to hit enter 3 times. Yeah.
What did you put in the window again?
For the window, I did 0 to 10 and 0 to 90. Yeah.
Can you explain why it's negative 16?
That part has to do with gravity.
Okay.
And that number is calculated based on the acceleration due to gravity. If you were doing meters per second instead of feet per second, you'd see the number negative 9.8 there instead of negative 16. I don't know exactly how it's calculated, I just know it's due to the gravity. On a different planet, it wouldn't be negative 16, unless it had the same gravity as Earth. Yeah.
There's something in there.
And you typed that in for your equation? Negative 16x squared plus 64x? Nope. What is the maximum height? Okay. Well, for maximum, yeah. Sure. We can find the maximum height on the calculator too. It's under the same menu that you do the intersect. Which option do you think I would use there to find maximum height? Yeah?
Number 4, maximum
maximum. And are we finding the maximum of what's in blue or what's in red? Red. So right now I'm on the wrong thing. If you press the up or down arrow, it'll switch the graph you're on. And now I'm on the correct graph. Now it's going to ask you 3 questions. First thing it asks you is pick a point that you know is to the left of the maximum. Hit enter. Pick a point that's to the right of the maximum. Hit enter. Hopefully I did. I think I did. And then it asks you for a guess. Just put the guess as close as you can to where the maximum is and hit enter one more time. And it says basically at 2 seconds, remember x is time, my rocket will hit a height of, what does it look like?
64.
How high?
64 feet.
64 feet. Yep. At 2 seconds, it hits a height of 64 feet. So to answer the question, what is the maximum height and when do we reach it? The maximum height is 64 feet, and this occurs at 2 seconds. So remember, x value is time, y value is the height. You might get like 2.000009. You might get a slightly different number here. Basically, the calculator can only estimate. It can't actually do algebra and figure it out perfectly, but it can figure it out within like 6 or 7 decimal places, which is close enough. All the calculator is really doing is guessing really fast. It's plugging like thousands of numbers per second in for t and seeing which one of them comes out the biggest. That's all the calculator is doing. It's probably taking like millions and millions of guesses within like a second and writing down the biggest one.
These things are kind of powerful.
Yeah, it does it pretty fast. You'll notice a little delay, but it's pretty quick. Any questions on that? Yeah. The maximum? So you do second calc, option 4. You have to make sure that you are on the correct graph, and I want to be on the red one, so I'm going to press the up arrow, or I could press the down arrow, and that'll move you between graphs. Pick a point somewhere to the left of the maximum, hit enter. Pick a point somewhere to the right of the maximum. You're just basically marking where the maximum is. Doesn't matter how wide you make it. It might give you the answer 1/1000th of a second slower if you make it a lot wider. And then the maximum, the last thing is the guess. Hit enter. And if you look this time, because of the way I did it, notice it gave me a slightly different answer. It says the maximum this time is 2.
And what was the difference in what you did?
I just made my left bound and right bound a little wider. So depending on how you set it, it can change your answer a little bit. But the y value still gave you 64. Okay, so when you see something that has like 5 or 6 decimals that are a 0, you can basically, we just round it. All right, and let's do the last thing. So the last thing we're going to look at drawing is what's called a piecewise function. And a piecewise function is basically 2 graphs drawn at the same time. The idea with a piecewise function is you say, okay, if x is under the number 0, I'm just using 0 as an example, I want you to plug it into this formula. If x is above the number 0, you use that formula. It's kind of like if you were to buy like tickets to an event. Sometimes there's one formula they use if you're under 18, like a child price, And then if you're greater than or equal to 18, there's a different formula for calculating adult price. So they break it up. So there's different formulas depending on the number that you plug in. So the domain is split into several parts. So like my last example, it would be numbers under 18 and then numbers 18 and higher. That's the split. And then depending on what number you get, you plug it into the correct formula. Either you get like the child price or the adult price. So I'm going to show you how to graph a piecewise defined function. It's similar to graphing a regular function on the calculator, but there's one thing that's different. That's what a piecewise defined function will look like when it's given to you. They'll give you a formula, and then after it, they'll give you a condition when to use that formula. So the top formula is used anytime x is under the number 1. Well, what if you're not under 1? What if you're 1 or higher? Well, then you plug it into the bottom formula. So like if I gave you the number 5, to get the answer, would you plug it into the top one or the bottom one? Bottom. What if I gave you the number 0? Would you plug it into the top or the bottom? What is it? The top. What if I gave you the number 1? Would you plug it into the top or the bottom? You'd plug it into the bottom. So it's just a different formula depending on what x is. And what I really want to show you is how you put that in on the calculator. So to put that in, well, clear anything else you already have. And the key here is you have to put it in parentheses. That's how you do it. So in y1, put 3 minus x squared, but put it in parentheses. Now, there's another part to that. You have to tell the calculator when to use it. You have to tell it when x is less than 1. So we're going to put that in parentheses next to it. X less than 1. I need to show you how to find the less than sign. I don't think I've shown you that. So in parentheses, put an x. And the inequality symbols can be found by pressing second, math, which is test. Yep. Press second, math. And the symbol that we want is which symbol this time? The less than, which is number 5. Let's do it again. So let's do the bottom. So in parentheses, type in the function, x cubed. Make sure after you do the cubed, press the right arrow so you don't stay typing up in the exponent. You want to come back down. X cubed minus 4x. And now next to it, put the condition for that one. In parentheses, x. And how do I get to the inequality symbol? Second test. And this time I want the greater than or equal to, which is number 4. And I'm putting in a 1. That is how you graph a piecewise function. So think of it as a function that's broken into pieces. And let's hit graph. And the calculator does a pretty good job. It's not perfect, but it's as good as we can do. I think Zoom 6.
You put a parentheses next to both of the inequalities.
Yeah, you have to do it just like that.
If I couldn't change the caret thing, how do I know that I'm out of the cube?
You should see the cursor drop back down. If it's still up high,
If mine it won't let me do it so it's like the exponent is like.
Oh, yours doesn't have the math print on. I'll show you how to turn them. Do you have one of my calculators?
No, it's from mine, but it's like the same like brand, so it's like.
You might need an extra parenthesis. I'll come help. I'll show you in 1 second.
Okay.
Okay, let's look at what we got. So notice the blue one, that's the 3 minus x squared. It looks like a parabola, but all of a sudden it stops. This part that's on the axis shouldn't be there in blue. There shouldn't be anything above the number 1 in blue, but the calculator can't do it that way. So what I do is if I just color over this in black, that is exactly how it should look. It's a parabola up until the number 1, and then at the number 1, it switches to a different function. Now, there's one other thing that it's kind of a little detail, but it's important. In the top one, x is less than 1. Would that be an open circle if you graph it, or a closed circle?
Open.
Open. So technically, there should be an open circle on the end of that graph in blue, indicating you cannot equal the number 1. Now, how about the red one? Is that open circle or closed circle? That's a closed circle. So now, looking at that as a picture, we know, okay, we can include 1 on the red graph, we cannot include 1 on the blue graph. And that's how a piecewise function should properly look. So the calculator does a pretty good job, but if we actually sketch it, we need to tweak it a little bit. Okay, and that's 1.3 part 2. Any question on that? So we'll go over that more tomorrow, and then tomorrow we'll do 1.4, which is all about y equals mx plus b, slope, so we'll go through that pretty quick. Okay, so that's the homework for tonight. What's that?
Merciful of you.
Yeah, tonight is a little shorter tonight. So it's 32 to 36, 45, 50 to 52, and 55 to 57.
I got you, Jack. I'm writing it down. All right, you got it.